Hello everyone! In this demo, we will learn how to create recipes and cookbooks with Progress Chef using a test-driven development approach. As you can see, we will be using the Visual Studio interface for all coding purposes. As a first step in this process, we will create and run a few test cases that are meant to fail. Based on the results, we will create cookbooks that cater to these test cases and ensure that they pass next time. We will start by creating a repository. The repository is the place where our code will reside. Here, the chef generate repo command is used to create a repository called Learn Chef. As you can see, the Learn Chef repository contains default folders like cookbooks, data bags, and policy files. We will explore these folders in detail at a later time. Though Chef creates default cookbooks, recipes, and YAML files for us, for the purpose of this demo, we will create our own custom files. To start with, we will create a new cookbook called Install Web Server within the cookbook directory. To do this, we need to navigate into our newly created repository, Learn Chef, and then to the cookbook folder. Notice that the cookbooks folder has a default folder called Example. However, we will create our own cookbook by using the chef generate cookbook command. As you can now see, a new cookbook called Install Web Server has been generated. Let us now create our custom recipe. First, let's change directory to install_web server. You can see quite a few default files. Now create the custom recipe file web server by running the command chef generate recipe. A recipe called web server gets created in the install_web server cookbook. Before writing the recipes, let's spin up two instances for us to test, namely an Ubuntu and CentOS instance with an EC2 driver. To do this, we must create our own custom kitchen.yaml file. As you can see, this YAML file contains code that will help us create an Ubuntu and CentOS instance with EC2 as the driver. Next, let's run the kitchen create command. Make sure that you run the command in the same folder where kitchen.yaml resides. The command will spin the two instances on EC2. Please be aware that this process might take some time. You can confirm the creation of the instances by using the kitchen list command. As you can see, both Ubuntu and CentOS 7 instances have been created. It's time now to create the test cases. In this scenario, we will attempt to install Apache web servers on both instances and start them up. This test case needs to be written in the default_test.rb file in the test directory. Let's remove the default code and now add our own custom code that tests whether the Apache servers Apache 2 and HTTPD have been installed for Ubuntu and CentOS respectively. To run the test, let's execute the command kitchen verify. The command will bootstrap both nodes. The output here shows that an apt update is running on the instance before any installation occurs. This is because we have used a simple lifecycle hook in the test kitchen. Lifecycle hooks are used to perform certain operations before the code is executed, such as this apt update. As you can see, the first test case fails because Apache 2 is not installed as a web server, while it is expected to be on Ubuntu. The second test case fails because HTTPD is also not installed as a web server for CentOS. This approach forms the basis of our strategy. Since both test cases have failed, in the next part of this video series, we will create recipes that will install the web servers and run test cases again to verify.